today we are starting our process of graphing rational functions. Okay, so what we're going to do to start out is we're going to actually just take problem number 1, and we're going to type it in the graphing calculator so you can see what it looks like. So what I'd like you guys to do right now, problem number 1, where it says f of x, turn on your calculator, hit y equals, because that's what f of x means, hit alpha, y equals, enter. And in the numerator, type in the number 4. In the denominator, type in, I believe it's x squared plus 3x minus 10. Just like that. Now, before you hit the graph button, there's something I would like everybody to do. I'd like everybody to turn their grid lines on if possible. So, hit second, zoom, go to where it says grid line right here. Go over there, turn the grid line on, if you would please. And then, if you're brave enough, hit the graph button. Let's take a look at what we have. And that's what my graphing calculator shows. All right? This graph is not a perfectly accurate graph of the drawing, but it will suffice. Now, what I want you to do right now is I want you to imagine if you had the power to draw a vertically straight line right there. Oh, that's not moving. Does everybody see where I'm drawing it right there on the grid? You can follow that. And right here, I'm going to draw another one straight down. I want you to understand this graph is actually getting really close to these dotted lines, but it's not actually touching it. So imagine, if you would, that it's going really close. And it was getting so close that the graphing calculator decided, I'm not going to graph it anymore because it's just too close. All right? So can everybody see the graph right here? What we're going to do in your graphing journal, we're going to graph this together. So right now, let's make a graph together. We're going to make a depiction of this particular rational function. So I'm going to pause the video and we're going to start the graph. All right, so what you're going to do is you're going to make an x-axis and a y-axis. In your journal, you're going to write f of x equals 4 over x squared plus 3x minus 10. Now, what you're going to also draw in is a couple of vertical lines. One is going to be right here at a positive 2. I think the other one was over at a negative 5. So right here at a negative 5, draw a couple of vertical lines just like that. You can go back and check on your graphing calculator to make sure you did it right. Looks like again. Negative 1, negative 2, negative 3, negative 4, negative 5, and a positive 2. Now, the next thing you're going to do is you're going to carefully, right here, hugging the x-axis, getting really close, you'll see your graph curving upwards, going forever up to heaven. And this one goes all the way up, and it gets really close to the x-axis, but never quite touches it. And then it gets close to this vertical line that you can't really see. It goes down forever. Then we have the last part of the graph, which is really close to this vertical line and also very, 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 very close to the x-axis. We're going to talk about what these vertical lines are called. All right? I want you to write this down in your journal. They are called vertical asymptotes. That is a new vocabulary word for something. All right? Vertical asymptotes. We have 2 vertical asymptotes. Whenever you pronounce that word, make sure you say it quickly so you don't get in trouble. Don't do a heavy front loading of the phonetical sound of the word, otherwise you might get in trouble. Just quickly get to the end. Now, the vertical asymptote is at a negative 5, and where x is equal to a positive 2. That actually is the answer to problem number 1, because it asks you to find the vertical asymptotes for problem number 1. So you can take that, transfer it over to your paper if you wanted to. We have 2 vertical asymptotes. Notice, they're boundaries. They don't cross over. They get right up to them, but they just keep going up. That right there is it's kind of like a line of discontinuity. Now, when you think of the word continuous, what do you think of? When I think of the word continuous, this is what I think of. I think of something just going forever and ever. Like, that line is continuous. All right? But if I have a line that starts and it goes up here, but then the other one goes down right here, there is not a connection between this curve and this curve. That's called discontinuity. So another way of thinking it, would this be considered continuous? Like that. This is a parabola. That would be continuous. Okay? So, the asymptotes, let's go back, right here, kind of separate the graph into three sections in this particular case. So how do we locate asymptotes without looking at a graph? That's what we're going to do next. We're going to zoom in right here on problem 1. So what I'd like you to do right now, in problem number 1, is just write this down in your journal exactly as it appears. Now, what if we didn't have access to a graphing calculator? Let me show you how to locate asymptotes and graphs without the use of a graphing calculator. The first thing you actually have to know how to do is factor. That's the first thing you have to know how to do. If you don't know how to factor, then go back to Algebra 1 and practice some factoring skills. That was a little too harsh there. Now, we are searching for two numbers that multiply together to equal a negative 10, but they add together to equal a 3. And if you ever have problems with factoring, always start with the factors, of the last number. So we're going to start with the factors of 10. What are the only factors of 10, everybody? 10 and 1 and 5 and 2. Only one of these sets can somehow lead me to a positive 3. Go ahead and say it, because I know this class knows the answer. Positive 5, negative 2. Positive 5, negative 2. 5 plus a negative 2 is 3. 5 times a negative 2 is negative 10. They meet both conditions. So you found the correct factor. So we're going to write here, put x plus 5 and x minus 2. Because together, if you were to FOIL those out, we get back to this trinomial right here. Now, in the world, there is a number that denominators do not like. You can never, ever, ever, ever divide anything into nothing. What number is the only number you're not allowed to have in the denominator? 0. Which means, right here, if I were to be evil and plug in a negative 5 right there, what would happen to this whole denominator? It equals 0. And if I were to take the number 2 and plug that number into this denominator, that would also make that denominator equal to 0. That's how you find your vertical asymptote. Any number that makes the denominator equal to 0, you've just found your vertical asymptotes. So your vertical asymptotes are equal to where x is equal to a negative 5 and where x is equal to a positive 2. That's why the answer to number 1 is your vertical asymptotes are located at a negative 5 and a 2. Or specifically, x equals a negative 5 and x equals 2. These equations represent vertical lines. If you're wondering, once again, what those vertical lines look like, right here and right here. Now, in problem number 1, you don't have to worry about this on this assignment. I'm just going to give you a little introduction real quick. There actually is a horizontal asymptote in play. The horizontal asymptote is actually located right on the x-axis. So if I said, label the horizontal asymptote, you could say the horizontal asymptote is where y is equal to 0. So you could put this in your journal just to kind of put that negative knowledge back in for later use when you are asked to find horizontal asymptotes as well as vertical asymptotes. But right now, we're only worried about vertical asymptotes. All right, on to number 2. We are not going to graph number 2 to start with. We're actually going to factor number 2. So what we're going to do right up here is I'm going to write 2x squared minus x minus 10, and we're going to think about how do we factor a trinomial that has the number 2 in front and not just the number 1. All right, because the other one was pretty easy. So please write 2x and x. And yes, you will continue to start with factors of 10, once again, this last number, which are still a what? 10 times 1 and a 5 times 2. All right, now when factoring these trinomials, I really, really need you to focus on the concept of the FOIL method. But not the first, not the last. I really want you guys to focus on these right here. The outside numbers and the inside numbers. So right now, the outside number is going to be equal to a 2x times some number. And the inside number right here is going to be some number times an x. So I need the product of the outside and the product of the inside, and what we're going to do is we're going to simply add them together, and we need that to equal a negative x right here in the middle. Okay? So here's the 4 different things that you can do. If you're using a 10 and a 1, or a 5 and a 2, one of them is going to be positive, one of them is going to be negative. You could put a 1 and a 10. You could put a 10 and a 1. You could put a 5 and a 2. Or you could put a 2 and a 5. Now, since we're doing a video, I'm going to show you the right answer. And then I'll show you why this is the right answer. I'm going to put a 5 and a 2 right here. So if I put a 2x, and I put a 2 right here, so 2x times 2 is a 4. So I put 4x. And then I put 5, bless you, 5 times x is a 5x. What would have to be the negative one in order for this to add together to equal a negative x? I want this, right? This would have to be the negative, which makes this number the negative, which means I got to put the negative there. Which means if that's the negative, then this one has to be the positive. So do you see how I'm setting it up? I'm working with the sum of the products of the outside and the inside, trying to get me this negative x right there in the middle. So let's think about this. I've got a 2x minus 5 times an, oops, we need to do an x plus 2 and x plus 2. So right now, what I'd like you guys to do is we're going to rewrite this answer. Here we go. In the numerator, we're going to have 2x minus 5 and times an x plus 2. And what binomial do we have in the denominator? 2x minus 5. So everybody, this right now is your function. This is your function. After you've done what? After you have factored this trinomial into 2x minus 5 and x plus 2. Huh. You guys see something that we can do? All right, we're going to cross this off. Cross this off. Now, this, whenever you eliminate something from the numerator and the denominator, you have not found an asymptote. You have found what's called a point of discontinuity. Now that is a long and fancy way of saying you just found a hole. A hole is considered to be a point of discontinuity. Imagine you guys were driving towards Shreveport, all right? And you're in Texas, and you're driving along. You automatically know, even if you're blind, when you hit Shreveport. Because suddenly, what do you start hitting in the roads? Points of discontinuity. Because they don't know how to take care of the roads. I'm just saying. All right? So, you were going along fine, and then you hit a pothole, right? That's considered to be a point of discontinuity. Which means, in a graph, everybody, if you had a line, but all of a sudden there was a break in the line where there was a hole, that's called a point of discontinuity. And that's all I have for this video.